Hey guys, this is Goofer King Science, and today I'm going to be showing you my homemade cathode ray tube project. This video will be split into two parts. The second part will go over the more technical aspects of the cathode ray tube, and why it does certain things. The vacuum pump I'm using here is made out of an old refrigerator compressor. The power supply is made using a variac and an oil burner ignition transformer. A variac, also known as an auto transformer, allows you to vary the voltage coming from a wall outlet without altering the waveform. The output of the variac goes directly into the oil burner ignition transformer. Normally, an oil burner ignition transformer takes in 120 volts AC and steps it up to about 10,000 volts AC at 23 milliamps. But when I vary the voltage coming into it, I can either lower or raise the voltage coming out. The actual cathode ray tube was built using a wine bottle and some stainless steel wire. I drilled a hole into the side of the glass bottle carefully using a glass drill bit and inserted a wire bent in a half circle shape. Then I secured it with hot glue to make sure it was vacuum proof. As you can see, I made two of them, and they each have the wire at different lengths down the tube. To create a vacuum inside of the wine bottle, I just attached a hose barb into the vacuum hose and slipped a rubber O-ring over it. When the vacuum is pulled, the rubber O-ring sucks down onto the bottle and it just seals itself. This way there is no epoxy or glues needed. Now it's time to power up the cathode ray tube. To do this, we need to attach some electrodes to the terminals of the oil burner ignition transformer. Next, we simply attach one of the other ends to an exposed piece of the hose barb and the other to that wire we added into the wine bottle. Now I turn on the variac and slowly and carefully turn up the voltage. As you can see, a beam of electrons, also known as a cathode ray, appears. It glows a bright purple color in my case due to small amounts of nitrogen and oxygen that are still left in the tube. Now, that time I was just running the tube on an AC current, so this time I'm going to add in a high voltage diode to make it a half-wave rectified current and see the difference in the beam. Now that we have that diode, let's power it up. As you can see, part of the beam that is glowing is only on one side of the tube. Last time it was on both sides, and there was a dark space in the middle. Now I'm going to demonstrate the magnetic deflection property of a cathode ray tube. Since it is a beam of electrons, it can be influenced by a magnet since electrons have a negative charge. Here I have a few magnets, and one side is marked with tape. When I put one side of the magnet that is marked up to the beam, it bends around it to the right. When I put the unmarked side to it, it bends around it to the left. Now I'm going to switch around the electrodes so that the electricity is flowing the opposite way. Now this time the dark space is on the other side, and when I hold up the marked side, now it bends around it to the left, and the unmarked side bends around it to the right. So depending on which way the electrons are flowing, they take a certain path around the magnet. Now I took out the diode and I'll show you the deflection of the beam when it's running on an AC current. As you can see, the beam appears to split around the magnet. Now, I told you earlier in the video that this is going to be split into two parts. The second part is going to go over the more technical aspects, describing why the beam splits and why it switches directions, if you're interested in that. I'll be using slow motion to analyze the cathode ray tube, and I'll show you some scientific formulas that explain some of the things that happen. Anyways, I'll see you guys later. Bye.